Hey everyone, I'm Robert with AWS. Today, we're here at the Reinforce Security Conference in Boston, and I have two special guests with me, James and Tom. Would you please introduce yourselves?
Hi, I'm James Devine. I'm a solutions architect on our federal financials team, and one of my areas of expertise is networking.
And I'm Tom Clavel. I'm product marketing for AWS Network Services.
Great to have you two. So, I understand that you're going to tell us how to easily and securely access services on AWS. Now, I personally have found a trade-off between security and ease of use. So this is a very appealing topic to me. Can you tell us a little bit more about this?
Yeah, I want to say that first, there's no such trade-off, not anymore. We see that network services more and more come up with essential security services. How you architect your network will determine how secure the network is and how secure your applications on the networks are going to be. You can isolate your resources using those network solutions. You can also encrypt the data, and you can also decide that you want to share the data privately as opposed to sharing it over the public internet. Mm-hmm. So all of these contribute to the security of your applications.
Yeah, so I understand that two of the ingredients for achieving this kind of network security are private link and global accelerator. Is that right?
Yeah, I think it's exciting the set of products that we have. So private link being the connectivity between VPC to VPC and being able to do so privately.
Yeah.
And actually, we'll dig into a little bit of that. And also our global accelerator, the ability to access your AWS services securely from the end-to-end from the AWS network, and also being able to have a static IP address, which both are very common asks from our customers.
Yeah, so can you break those two elements down? And maybe we can start with, like, what if we didn't have that? Before these services existed, what was the problem?
Yeah, so before both of these services, and Private Link came out about 2 years ago at reInvent, and a Global Accelerator last year at reInvent. So before that, there really wasn't a good way with Private Link to extend services into another VPC. You needed to do VPC peering or do a transit VPC, both complicated and difficult to manage. And we like to invent and simplify, so we came up with Private Link in that case.
Yeah, so that's kind of creating an overlay between two VPCs in a more managed and seamless way. Is that about right?
Yeah, and if we could go to my screen, I can show kind of a simplified way of what that looks like. So I can see here I have a consumer and a provider VPC. So I'm pretty much extending my network load balancer into a consumer VPC from a provider VPC. So the advantage here is that there can be duplicate IP addresses, they can be overlapping IP addresses. It really doesn't matter. Private Link handles that all on the back end using our hyperplane technology.
Mm-hmm. And this is great because this means that you can kind of keep that clean architecture while adding in all these features that you need, and you still get some of the guarantees and some of the separation that you get with a VPC, right?
Yeah, customers are always excited when I talk about this to have that private connectivity and that route into a VPC, and it's also a one-way connection. So from that VPCE to that network load balancer, or be it AWS service, we have that private connection, and that's not something that the anybody can't go the other way. It's a one-way communication flow.
Yeah. Now, is this feature only available within a single region, or can you use this to link VPCs across regions?
So currently it is a regional service, so you can launch it in individual regions, and we keep that fault domain. You do have the ability through inter-region peering to access private link endpoints, though. So there is that option for, and I've talked to customers that have use cases that want to be able to do that.
Yeah. So maybe you can walk us through a couple of examples. Like, where have you seen this? What is a full end-to-end scenario where you've seen this kind of solution really make sense?
Sure, and I'll move to my next slide here. So this is kind of an example of how it works for AWS services. We're able to connect from an instance to a VPC endpoint into the back-end AWS service. So that's all using private IP addresses that exist within my VPC. So say, for example, I wanted to access EC2 Systems Manager, I can access that service without any route to the internet. And we can see on this diagram on the right, the internet is actually not even in the picture here. It's outside of my VPC, and we're not using it at all.
Speaking of the internet, I mean, I guess this seems like a solution, again, for data center to data center communication, intra-service communication, intra-VPC communication. What about when I have an endpoint that's out on the internet and I want to get that onto the network, onto the Amazon Global Network as quickly as possible? What do I do there?
So that's really more the application of Global Accelerator, being able to use our global backbone to access services directly.
Yeah. Do you have slides for that? Can you show us how
Yeah.
that works?
Sure. So this is an example with lots of animations. So this is an example. So the way Global Accelerator works is we advertise an IP address, 2 public IP addresses actually, out of each of our edge locations for high availability. So we have redundancy there. And from there, the applications, your end users will access the closest edge location. We're using what's called BGP Anycast. So we're able to advertise that IP address out of multiple locations, and it'll pick the closest location to traverse and access the AWS network. So the idea is we get the customer traffic onto the AWS network as quickly as possible, where we control that traffic flow end to end. So it's low latency, high speed. And you can see here we access the services directly. So for applications like gaming and other services where you need low latency and high bandwidth, but also for static IP addresses. So a lot of customers want to hard code or need to hard code a single IP address or 2 IP addresses into their firewall. This allows them to do that.
Yeah, so and then this static IP address that you have here, you can stick into a DNS entry, and then when you resolve that DNS entry, you're automatically getting routed to the nearest data center with the lowest latency and the highest bandwidth.
Yeah, exactly. That's exactly how the service works.
And then all of this Anycast craziness, you get all of that just for free without having to do anything else, reconfiguring any special clients, right?
Yeah, the nice thing is we really enable the end user to set this up and get it up and running. I've talked to a lot of network engineers, and they scratch their head and they start talking about ASN, autonomous system numbers, and BGP Anycast and IP addresses, and they want to really get their head around it. But like everything AWS, we just deliver it as a service.
Yeah, and I think it's also, maybe you have a diagram here. Maybe if you don't, I think the AWS Global Accelerator, sorry, is really getting your traffic onto the global network, and the global network is a big deal, right? I mean, this is one of the differentiators that makes AWS special. This is the largest footprint public infrastructure network available, and if you watch the keynote, it's built using over 2.6 million miles of fiber. That's crazy. I mean, just the sheer scale of this network really amazes me.
So indeed, and Global Accelerator is a great way to leverage that global network by routing the traffic to the endpoint that is closest to your user. So your traffic remains on the global network as much as possible. It is secure while it's on the global network, and then the traffic gets routed to that endpoint. If you have a disaster, that endpoint can actually be automatically failed over to another endpoint. So it's also great for disaster recovery. It's great for latency-sensitive applications like gaming. You have a global range of users all around the world who are playing games, and they need to have very low latency. Global Accelerator is going to help for that. And as you pointed out, scaling, you can scale globally your applications because now you can deliver those applications anywhere around the world.
Yeah, and now I think when you describe that set of features, you're starting to describe what a lot of people have used in terms of a content delivery network. So maybe you can talk about the differences between the Global Accelerator versus CloudFront briefly.
Yeah, so CloudFront would be more of caching, our CDN, using CloudFront. So we have over 100, I think, over 130 POPs now. We're constantly bringing more and more POPs, a point of presence online. It's hard to keep the numbers straight in my mind. It just always gets bigger. So that's more for when you want to cache content at the edge, where Global Accelerator really doesn't do any caching at all. So we're terminating that, or we're taking that connection and egressing it onto our network, ingressing it onto our network as quickly as possible, and then it traverses our private backbone. So say here in Boston, you were to set up a Global Accelerator, it would hit the global network and then traverse to the nearest region. And it doesn't need to be in that region. It could be anywhere around the world, and it'll traverse our private network and get there. It also can help out with availability, and so we can automatically fail over from an unhealthy region to a healthy region, and also make sure that when traffic comes into the network, it's going to the closest region that you have infrastructure up and running.
Yeah. Yeah, so I think that's a good point. I mean, when you build out a distribution on CloudFront, CloudFront is our content distribution network. You are pushing these resources out to the edge, so that when customers ask for those resources, it's being served out of the edge. Whereas what I'm hearing you is correct, the global accelerator will forward that connection, forward that traffic to the nearest data center. So it's going deeper into the infrastructure than CloudFront would, if that's a fair way to describe it.
Correct, and we're not terminating that. We're not terminating that connection or any way interfering with it. We're just rewriting the packets and directing them onto our network.
So then, speaking of the connection, I mean, what kinds of transports do we support? Because I know CloudFront is purpose-built for HTTP, and most types of resources fetched over HTTP, so HTML, JS, CSS. But it sounds like with Global Accelerator, I can have a persistent TCP connection and get that routed to the nearest data center. Is that a feature that we support?
Correct, yeah. Both TCP and UDP traffic on pretty much any port, so you can open it up and set it up, and we can dig into the console and show what that actually looks like.
Oh, that would be wonderful. But before we do that, what about WebSockets?
Yeah, you can support WebSockets as well, because we're just at the TCP or UDP layer, so that allows you to run essentially whatever backend application you'd like to, as long as it supports TCP and UDP.
That's fantastic. Well, I want to see the demo.
Sure. Let me pull it up and log into my AWS account. So if we go under our long list of products and services, I like to type in and start typing in as opposed to navigating through all the different options here. So if I go to Global Accelerator, I've created one specifically for this event for Reinforce. So within a Global Accelerator, there's listeners, and these listeners are on a specific port. So here I can see this is port 80, and this is TCP, so we mentioned it does both TCP and UDP, and I can see everything is healthy. I can also see these two IP addresses here that are the two IP addresses that are the Anycast, BGP Anycast IP addresses. So these are what you'd put either a Route 53 entry into a hosted zone, or you can just have customers point to it directly. It really depends on your application, but you'd want to use both of them for high availability.
So is that just a regular A record that I put into Route 53, or is it a special record of some sort?
Yeah, a standard A record will work because they're static IP addresses, and you can do additional health checks within Route 53 if you want to add additional resiliency there. So I can see here, this is just my congratulation page. I just used a simple LAMP stack, so Linux, Apache, MySQL, and PHP. So I have this up and running. Same thing happens when I type in the other IP address as well. Just comes up and loads. Nothing too special there, but I mean on the back end where my traffic is traversing the network at the closest POP and then traversing AWS's global backbone to get to my infrastructure. Mm-hmm. And this happens to be running in US East 2. What I can do if I go into this listener, I can see my endpoint groups, and these are regional. Here I can do a traffic dial, so if I wanted to send 50% of my traffic to one region, 50% to another region, or any combination thereof, I can go and actually have that granular control. Mm-hmm. So here I'm just going to go through and add another endpoint group. So I want to do this in US West 1, Northern California. And I'll keep this traffic dial at 100. And I'm going to want to add an endpoint. And for here, my options when I add an endpoint, it can be an application load balancer, a network load balancer, or an elastic IP address. So it's pretty flexible in what you can actually put behind this. So here I'm going to do an elastic IP address. I only have one elastic IP address in this region. I can also assign a weight here if I wanted to do some weighted routing as well. And I'll go ahead and save. And since this is just added, you'll see here there's a red mark. Just the health checks haven't had a time to check this to make sure it's healthy yet. But I can now see I have US West 1 and US East 2. So I have my application running on both coasts now, running through Global Accelerator. And if one of them were to fail, my traffic would automatically fail over to the other one. And I'm able to also serve traffic from the load balancer in the closest region.
But you've got traffic dial at 100% for both. What does that mean?
That means that both endpoints are receiving that traffic at 100%. I could do 50% here, and then that would round robin do some load balancing between the regions. But this type of setup would give you the lowest latency. So users from the East Coast would go to the East Coast region, and users from the West Coast would go to our West Coast region. So providing low latency there.
Okay, but I'm for my benefit, if you had set, let's say, if we set the first US East to 50% traffic, what would that actually mean? If there were a request coming from US East, what happens?
So from US East, that means we only direct half of that traffic coming into that endpoint to that specific endpoint group.
I see.
Yeah.
Okay, and then the other half is then bounced to US West?
Yes. So when traffic enters Global Accelerator, it has a preference to go to the local region. So for here, we're in Boston, so my traffic would go to US East too, just because that is the closest region. Mm-hmm. But if I set that to 50%, then we'd balance between sending some traffic to the East Coast and some to the West Coast.
Is that capacity based or is that usage based? Is it round robining? Like let's say I'm the only customer and I'm just hitting refresh. I'm reestablishing these connections from from Boston, let's say. Is it every other connection is going to US East, US West, US East, US West, or is it exhausting some capacity before it routes over? Do you know?
It's just the traffic volume, so it's based,
okay.
As you refresh, you could potentially get bounced around.
Yeah.
Setting up to 100, though, that assures that you're entering the local region and have the lowest latency.
Okay.
So probably more of a common scenario.
So 100 traffic dial is the common setup here, just to make sure that anybody can be routed to any region. That's what you're saying, right?
Correct, yeah.
I see. That's really cool.
Yeah, I think it's pretty fascinating. It's not many days you can just go into the console, click a button, and launch a global network.
Yeah. That's one of my favorite things about AWS, honestly. And I see this in DynamoDB, for example, with global tables. The ability to just go and like click. Okay, now I have a database that's replicating my records from one region to another region, all the way across the world in seconds. This kind of workflow used to take so much manual labor and messing around with configuration settings and virtual machines. It used to take so much work to deploy that, and we see that more and more with that feature available with more and more services, where with the click of a button you get global presence. CloudFront is a great example. Your distribution suddenly spans the entire world in a matter of minutes. This Global Accelerator seems to be a great example of this. But that's I think one of the really cool things about AWS.
Yeah, and as my day job as a solutions architect, talking to customers about this great platform we have and all of these products and features and the pay-as-you-go pricing, you could go and I launch this in the console, and this will probably cost a few pennies to set up a global network, which is kind of still mind-boggling to me. And I've been here a long time doing this.
Yeah. Now you've there's this one more question I had to ask about the traffic and the routing and the stickiness. Do you get any sort of stickiness? Can you configure it so that my client has a preference for a particular region after it's initially connected?
Sure, and that's actually a great question. So if I go in here, I can actually I believe it's at the listener level. Nope. At the endpoint or listener ID, for the listener, this client affinity here, I can go in and edit this setting, and based on the source IP address, I can have client affinity. So you might want to do that. So to your point earlier about putting that dial down to 50, I could be routing traffic around and lose that affinity, and then the session wouldn't be maintained.
Yeah.
So here we're able to take that source client IP address. So now if I come in, I'll be directed to the same backend instance, regardless of the traffic dial here.
Yeah, and for those of you watching, I think this kind of feature starts to matter when you have a lot of cache warm-ups that needs to happen. Let's say that cache is scoped to a particular region, and the first time the client connects, it's going to cause the service to cache in a bunch of data, and that may incur a performance hit. But what you're banking on is that subsequent connections are really fast because the data is readily available. And once you warm up the cache, you want to be able to say, okay, well, there's some affinity in the connection now, so that I can take advantage of the fact that it's already cached in. If you keep bumping around regions randomly, you don't get to take advantage of that anymore. And there are other benefits too, but I think that's one of the main reasons I've seen that people use some sort of sticky routing.
Yeah, definitely.
Yeah. All right, well, I mean, I've learned a lot. Thank you very much for taking us through the features here. Is there any other closing statements you'd like to make?
Well, I had a whole private link demo prepared as well, but I think we're running out of time here, so as things typically go. But I think the exciting thing there, and I wanted I can talk at a high level, is the ability to have a private connection into a VPC. So I actually set up or EC2 Systems Manager, and I use Sessions Manager with private link endpoints in the VPC. I can securely access that instance, pull up a terminal with no connectivity to the internet, no connectivity to any other VPC. I'm just using VPC endpoints, and our systems manager, I'm able to connect in and securely access the service. And it's all logged into S3. Every command that gets put in is logged. So kind of a good surrogate for a Bastion host, and it can really simplify and help customers deploy secure remote environments.
Yeah, that sounds like a really cool demo as well. We'll have to get you on stage again so that we can demo that sometime.
Sure, I'd love to.
All right. Thanks, everyone.
Thanks.